Hello everyone. So in this lecture we will be doing exemplar from the chapter integration. So this is our first question and notes for the lecture will be available below the video, and there will be timestamps also so that you can jump to any of the questions that you are trying to solve. So let's proceed to our first question. तो इसमें हमें जो integral given है, here we will use x square is equal to t as a substitution, and just we will use just for partial fraction, not for integration. ठीक है? For partial fractions I will use this substitution, because you can see if I do this polynomial by polynomial will become t by t square minus t minus 12. So t square minus t minus 12 can be factorized. So we can do t square minus 4t plus 3t minus 12. So which is t common. So t minus 4 plus 3 common, t minus 4. So which is t plus 3 into t minus 4. So this partial fraction will become t divided by t plus 3 into t minus 4. So we can probably write this as a by t plus 3 plus b by t minus 4. Let's find a and b. So जब एलसीएम लेके डिनोमिनेटर्स को कैंसिल करेंगे, we will get a times t minus 4 plus b times t plus 3, and denominator cancel होगा. So let's compare coefficient of t from the left side, so which is 1, and right side में वो आ रहा है a plus b. Constant coefficient on the left side is 0 and right side में आ रहा है minus 4a plus 3b. So we have to solve these two equations. So what I will do, minus 4a plus 3b को ऐसे ही लिख देते हैं. This is equal to 0, and second वाली equation को 4 से multiply कर देते हैं. So 4a plus 4b is 4. So let's add these two, and these two will cancel, and we will find 7b is 4, and we find b is 4 by 7. Okay, and now let's try to find a. So we know a plus b is 1, so a plus b is 1, and b is 4 by 7, so we find a is 1 minus 4 by 7, which is 4 by 7, which is 3 by 7. Okay, so we got the value of a and b. So now with this I can write this integral as, so पहला टर्म आएगा a, which is 3 by 7 divided by t plus 3, but t क्या x square, so x square plus 3 plus 4 by 7 divided by x square minus 4, so b divided by t minus 4 dx. Okay, so which is a very simple integral. दोनों के दोनों standard formulas है. So 3 by 7 outside, first integral is 1 by x square plus root 3 का square, so plus dx. Second integral is 4 by 7 outside, 1 by x square minus a square का integral है minus 2. So we'll apply our formulas. So पहले वाले का integral कितना होगा, 1 by a, so 1 by so if it is not visible I'll go down. Okay, so 1 by root 3 tan inverse x by root 3 plus 4 by 7 into 1 by 2a, 1 by 2 into 2, log mod x minus a, x minus 2 divided by x plus 2, okay, plus c. So let's simplify this. So we'll get root 3 by 7 tan inverse x by root 3, and then 4 cancels, so 1 by 7 log mod x minus 2 by x plus 2 plus c as the result for this question. So let's check the answer. Yeah, that is correct. So let's move to our next problem. Okay, so in this next problem, we have to solve the question similarly. Uh, we will use x square is equal to t, but we will use it only for partial fraction. So using that, our fraction will look like t divided by t plus a square into t plus b square. So we can use partial fractions and we can say this can be written as a by t plus a square plus b by t plus b square. So after taking the LCM, we get a into t plus b square plus b into t plus a square is t. So from coefficient of t, I can find equation which says a plus b is 1, right? And from constant coefficient, I can find 0. Left side में 0 है, right side में it is small b square into a, so capital A into b square plus b into a square. So we have to solve these two equations to find capital A and capital B. So let's use method of elimination. तो मैं पहली equation को b square से multiply कर देता हूँ. I will get b square A plus b square b equal to b square, and second equation is b square A plus a square b is equal to 0. तो subtract करते हैं दोनों equations को. तो मैंने first equation को b square से multiply, that second equation into 1. So these two cancel and we get b square minus a square into b is equal to b square. So we find b is b square divided by b square minus a square. Okay, so now let's try to find a. So we already know a plus b is 1. तो b की वैल्यू डालेंगे एंड a की वैल्यू मिल जाएगी 1 minus b, which is b square divided by b square minus a square. So this is b square minus a square minus b square divided by b square minus a square. So b square cancels and negative मैं absorb कर लेता हूँ, and so a square divided by, I can write a square minus b square, right? So, and if you want to, you can keep negative sign also. So now we have got the value of a and b, so we can use our partial fraction now to write this integral. So अब इसमें दो terms आ जाएंगे. So first is a, which is a square divided by a square minus b square divided by t square plus a square. So this term and this term. So but t क्या है? T is x square, so x square plus a square plus b square divided by b square minus a square divided by x square plus b square dx. तो पहले वाले टर्म से we can take common a square by a square minus b square, and we have integration of 1 by x square plus a square, which is 1 by a tan inverse x by a, and plus second में से we can take out b square and b square minus a square, and integral is 1 by x square plus b square. So we get a square minus b square into 1 by a tan inverse x by a plus b square divided by b square minus a square into 1 by b tan inverse x by b plus some arbitrary constant. So on simplification, let's take 1 by a square minus b square common. So second वाले इंटीग्रल में नेगेटिव आ जाएगा, एंड यहाँ पे एक a कैंसिल हो गया एंड यहाँ पे एक b कैंसिल हो गया. So we will get a times tan inverse x by a एंड नेगेटिव साइन के साथ, क्योंकि मैंने a स्क्वायर माइनस b स्क्वायर कॉमन लिया. सो b टाइम्स tan inverse x by b plus some c. Okay, which is the same result as given in the back side of the exemplar. So let's move to our next problem. Okay, so in this question, so this is a question जहाँ पे हमें definite integration का property use करना है. So I will call this integral as I, and I will mark this as first equation. And what I will do is apply the property that 0 to a f of x dx is same as 0 to a f of a minus x into dx. So using this property, our integral will become 0 to pi minus x divided by 1 plus sine of pi minus x dx. So यहाँ पे dx missing है, so let's write that. So which simplifies to 0 to pi minus x divided by 1 plus sine x, because sine of pi minus x is sine x. So we will call this as equation 2, and we will add 1 and 2. 1 plus 2 करेंगे to eliminate x. So we get twice of I is equal to 0 to pi, and ऊपर बचेगा x plus pi minus x. So ये दोनों कैंसिल हो गए एंड pi बचेगा बस 1 plus sin x dx. So now it's a very simple integral, pi by 2 outside, 0 to pi 1 by 1 plus sin x. तो इस इंटीग्रल को कैसे करेंगे, बट वी विल जस्ट रैशनलाइज दिस टर्म. तो इसको रैशनलाइज करने के लिए वी विल मल्टीप्लाई विद 1 माइनस साइन एक्स एंड 1 माइनस साइन एक्स. So this integral will become I is equal to pi by 2 0 to pi 1 minus sin x divided by 1 minus sin square x क्या होगा, which is cos square x, right? And cos square x से divide करेंगे, we will get 0 to pi secant square x minus, so sin x by cos x is tan x and 1 by cos x is secant x. So okay, so let's proceed. I is pi by 2 outside, integration of secant square x क्या होगा. So let's just do that. Secant square x का integration is tan x and limits are 0 to pi, फिर माइनस साइन है पाई बाय 2 है और tan x into secant x का इंटीग्रेशन है secant x 0 to pi. तो I is pi by 2 tan pi minus tan 0, both are 0, minus pi by 2 secant pi minus secant 0 secant pi होता है -1 and secant 0 होता है 1. तो I is minus pi by 2 -1 and minus of 1. So this simplifies our integral to minus pi by 2 times minus 2. So negative negative positive and 2 cancels and we get integral as pi, which is the same answer as the exemplar. So let's move to our next problem. Okay, so this is a simple question of partial fraction. So we'll write 2x minus 1 divided by x minus 1 into x plus 2 into x minus 3 as a partial fraction, which is a by x minus 1 plus b by x plus 2 plus c by x minus 3. So after taking the LCM, we will get x plus 2 into x minus 3 here and b के साथ में x minus 1 into x minus 3 and c के साथ में x minus 1 into x plus 2 and all of this is equal to 2x minus 1. So एक step और लिख लेते हैं. So 2x minus 1 is a times x square minus x minus 6 plus b times x square minus 4x plus 3 plus c times x square plus x minus 2. Okay, so now let's compare the coefficients. So x square का coefficient compare करते हैं. So we find 0 is equal to a plus b plus c. So x का coefficient compare करते हैं. So we find 2 is equal to minus a minus 4b plus c plus c. The constant coefficient which is minus 1 and this is equal to minus 6a and plus 3b and minus 2c. Okay, so now we need to solve these equations. So क्या करते हैं कि c eliminate पहले कर देते हैं. So इन दोनों equation से from 1 and 2 1 and 2 से मैं क्या कर रहा हूँ उनको subtract कर रहा हूँ तो c गायब हो जाएगा. We'll find twice of a plus 5b. तो subtract किया c cancel 5b add हुआ a add हुआ ये subtract होगा is minus 2a minus 2 and from 2 and 3. So 2 and 3 से what we can do is हम 2 को सेकेंड इक्वेशन को 2 से मल्टीप्लाई कर देते हैं. So we will have minus 2a minus 8b plus 2c is 4 and minus 6a plus 3b minus 2c is minus 1. So let's add them and cancel these two. So we have minus 8a minus 5b is 3. So let's call these two equations as a and b. So a and b को solve करते हैं. So these were 1, 2 and 3. So from a and b इन दोनों को ऐड कर देते हैं. ठीक है, तो 5b कैंसिल हो जाएगा and we find minus 6a is equal to 1 and we find a is equal to minus 1 by 6. तो a और b के लिए b अब निकाल लेते हैं. b can be found from equation a. So we find from a twice of minus 1 by 6 plus 5 times b is minus 2. So 5b, so ये 2 यहाँ cancel हो. This is minus 1 by 3 minus 2 plus 1 by 3. So we find let's see. So we find 5b is -6 plus 1, which is -5 by 3, and -5 और 5 cancel हो गया, so 5 is -1 by 3, so B is -1 by 3. So we already know A plus B plus C was 0, I guess, है ना? So first e- first equation से, so A plus B plus C is 0. This is from 1. So A की value -1 by 6, B की value -1 by 3, plus C is 0. So C is 1 by 3 plus 1 by 6. LCM is 6. 2 plus 1. So 3 by 6, which is half. So हमें C की value मिल गई as 1 by 2. So let's use -1 by 6, -1 by 3 and half in our partial fraction. So our this integral will change and this will become A, which is -1 by 6 divided by x minus 1, plus B, which is -1 by 3 divided by x plus 2, plus C, which is half divided by x minus 3. So -1 by 6 outside, integration of 1 by x minus 1 dx, -1 by 3 outside, integration of 1 by x plus 2 dx, plus half outside, integration of 1 by x minus 3 dx. So we get -1 by 6 log mod x minus 1, -1 by 3 log mod x plus 2, plus half log mod x minus 3, plus some arbitrary constant as the result. And अगर ये एग्जाम्पलर के पीछे शायद कंबाइन करके आंसर दिया हो, सो यू कैन ऑल्सो डू दैट. सो दिस इज 1 बाय नेगेटिव बाहर छोड़ देते हैं, सो log mod x minus 1 की power 1 by 6, right? And then minus outside log mod x plus 2 की power 1 by 3, and plus log mod x minus 3 की power half plus c. सो लॉग के तीनों टर्म्स को कंबाइन करते हैं. सो प्रोडक्ट में जो नेगेटिव है वो डिनोमिनेटर में आएंगे, जो पॉजिटिव है वो ऊपर आएंगे. सो विल गेट दिस टर्म अबव व्हिच इज स्क्वायर रूट ऑफ x minus 3, एंड डिनोमिनेटर में क्या आ रहा है, x minus 1 की पावर 1 by 6, x plus 2 की पावर 1 by 3 mod plus c. ओके, तो एग्जाम्पलर के पीछे शायद ऐसा आंसर गिवन. तो probably a easy question, simple partial fraction का. So let's move to our next problem. Okay, so let's proceed with this question. It's a good question for 4 marks for school exam. So first thing we notice is हमें e की पावर x का इंटीग्रेशन तो पता है, बट e की पावर tan inverse x हमें नहीं पता. बट tan inverse x का डिफरेंशिएशन इज 1 by 1 plus x square, which is available in this. So probably we'll use that as a substitution. Let's use tan inverse x is equal to some t. So 1 by 1 plus x square into dx is dt. So अब ठीक है, कुछ कुछ चीज़ें तो आराम से ट्रांसफॉर्म हो जाएंगी. ई की पावर ये t बन जाएगा 1 by 1 plus x square into dx. So this term into this term will be dt. But what about 1 plus x square? तो हम यहाँ से क्या करते हैं, from the original equation let's find the value of x. X is tan t. So 1 plus x, so which is tan t, plus x square. So plus x square, which is tan square t. So into dt, right? Okay. So 1 by 1 plus x square into dx is dt. So अब 1 प्लस tan स्क्वायर कितना होता है? Secant स्क्वायर होता है. So this is e की power t into tan t plus secant square t. And this becomes a very very simple problem from integration by parts वाले exercise का. We had a formula there कि e की power x fx plus f dash x dx. So by integration by parts you can always prove that this is e की power x into fx plus c. So here we can take ft as tan t and उसका differentiation क्या है f dash t which is secant square t. So इस particular integral का answer will be e की power t into tan t plus c. Okay. So but t की value हमें वापस put करनी है. So tan t was x and t was tan inverse x. तो इस क्वेश्चन का आंसर बन जाएगा e की पावर tan इनवर्स x एंड tan t की जगह क्या आ जाएगा x. ठीक है. सो x टाइम्स tan इनवर्स x e की पावर tan इनवर्स x प्लस c is the result for this question. Okay. So let's move to our next problem. So this is our next question. So it may feel like कि जैसे हमने पहले भी देखा था a minus x by a plus x एंड यहाँ पे हमने सब्स्टिट्यूशन यूज किया था x is equal to a cos 2 theta. So which worked fine because this became a minus a cos 2 theta divided by a plus a cos 2 theta and a got cancelled and 1 minus cos 2 theta by 1 plus cos 2 theta. So which gave us the result 2 sine square theta by theta divided by 2 cos square theta. And we got tan theta as the result, so it got simplified. But this substitution will not work here. So if you try the same substitution here, so a cos 2 theta, so this will become so x, right? So यहाँ पे आ जाएगा a cos 2 theta divided by a plus a cos 2 theta. So a got cancelled and we get cos 2 theta divided by 1 plus cos 2 theta. So maybe you can try to write this as 2 cos square theta minus 1 and this one as 2 cos square theta, and this will not get simplified. You will get 1 minus half secant square theta. So simplify नहीं होगा तो solve ये तो integrate हो जाएगा, right? So this one is not looking good. So here the substitution that will work is x is equal to a tan square theta. So अब कैसे इमेजिन करें कि क्या होगा? So to do that, for example यहाँ पे आप डोमेन को स्टडी कर लो, right? So this in this one, if you look at this, so a minus x by a plus x. So you can always study कि a minus x should be greater than 0 क्योंकि वो स्क्वायर रूट के अंदर है. So from that you get x should be less than a, right? And you can see a plus, so greater than equal to भी चलेगा ऊपर, but a minus x, sorry, a plus x also should be greater than equal to 0. So from that we can get x should be less than minus a. So greater than equal to minus a, equal to का साइन नहीं आएगा डिनोमिनेटर में हो, but you get the point कि x is between, so equal नहीं आएगा डिनोमिनेटर में है. So we get x is greater than minus a. So from both of these conditions you can imagine x by a should be between minus 1 and 1, right? ठीक है. So इसलिए हमने substitution जो cos theta का use किया था that was working fine. But यहाँ पे ऐसा कोई condition है क्या? So let's study the domain here. So यहाँ पे root x given है ऊपर और नीचे क्या है? a plus x. So x should be greater than 0 numerator से, right? Equal to भी आ सकता है. एंड नीचे से आ रहा है a plus x should be greater than 0, so x should be greater than minus a. so first and second condition का intersection क्या आ रहा है, so इससे हमें मिल रहा है x should be just greater than 0, right? ठीक है, तो ऐसा कौन सा ट्रिग्नोमेट्रिक फंक्शन होता है जो 0 से इंफिनिटी के बीच में जाता है? तो well, tan theta goes from minus infinity to infinity, but if we use tan square theta, right? ठीक है, tan theta कहाँ से कहाँ होता है, infinity to minus infinity होता है, but tan square theta looks useful because this is between 0 to infinity, right? ठीक है, and this will work fine with this condition, this domain, right? And you can see यहाँ पे substitution क्या use हो रहा है, tan square theta. So you can always study the domain to find a proper substitution also. So let's use this substitution and try to solve this problem now. So हमारा integral है sin inverse square root of x by a plus x dx. So let's use our substitution कि x is equal to, so हम a किस लिए लगा रहे हैं ताकि ये और ये ऊपर से a कैंसिल हो जाए, right? And tan square theta, so and we get dx should be equal to a times 2 tan theta, so x square का differentiation and tan theta का differentiation secant square theta, then d theta. So okay, so dx is 2a tan theta secant square theta d theta. Okay, so this integral will change and this will become sin inverse a tan theta divided by a tan square plus a tan square theta dx. dx की जगह क्या आएगा, तो 2a tan theta secant theta d theta. So very large integral but not very difficult. Let's proceed it one step at a time. So integral के अंदर our a will get cancelled and we will get sin inverse tan square theta divided by, so what is a cancel हो गया तो 1 plus tan square theta is secant square theta, so this is into 2a tan theta secant square theta, so tan theta, so let's remove this 2. So tan square theta is sin square theta by cos square theta, so sin square theta by cos square theta and secant square theta ऊपर जाके बन जाएगा cos square theta. So this is, I'm talking about this term, right? Okay, and this is just sin square theta. So ये simplify हो गया, sin inverse square root of sin square theta, 2a outside tan theta secant square theta d theta. So square root and square remove हुआ and sin inverse sin theta is just theta. So this is 2a integral of theta into tan theta secant square theta d theta. So probably we will use by parts, and this is our first function which is the algebraic function and this is our second function which is the trigonometric function. So isolate अगर हम देखें, so this is our algebraic theta and this is our trigonometric function tan theta into secant square theta. We can see theta is difficult, we will so algebraic is difficult than trigonometric, so we will take out theta outside and integrate the trigonometric part. Okay, so बाहर 2a है, I'm sorry, so this becomes 2a, so by parts का formula u v dx So u outside v dx minus d dx of u and then v dx and whole thing in a bracket dx. So integration by parts. So by parts से इसको करते हैं by parts. So 2a outside. I'll use a bracket. So theta outside and integration of tan theta secant square theta d theta minus dd theta of theta and integral of tan theta secant square theta d theta. So I'll use a whole bracket d theta and bracket close. So this integral is very easy. The tan theta into secant square theta. So you can take tan theta is equal to z secant square theta into d theta will be dz. So this will become z dz and z square by 2 आंसर आ जाएगा. But z क्या था? Tan theta. So this is tan square theta by 2. So let's use this integral into this. So ये दो जगह आ रहा है. So this is 2a theta into tan square theta divided by 2 minus integral of 1 into tan square theta divided by 2 d theta. So let's multiply 2a inside and 2 cancel. We get a times theta into tan square theta. Second वाले इंटीग्रल में भी 2 कैंसिल हो जाएगा and we'll get minus a times integral of tan square theta d theta. So this is a theta tan square theta minus a. So tan square theta can be written as secant square theta minus 1. So a theta tan square theta minus. So secant square theta का integration is tan theta and minus 1 का integration is minus theta. So plus c. So a theta tan square theta minus a tan theta plus a theta plus c. But हमारा question was then not in terms of theta. It was in terms of x and we use the substitution x is equal to a tan square theta. So we already have the value of tan square theta. The tan square theta हमें इस equation में चाहिए which is x by. ठीक है, हमें इस equation में किसकी वैल्यू चाहिए? tan theta की वैल्यू भी चाहिए which we can find to be square root of x by. एंड हमें इस इक्वेशन में थीटा की वैल्यू भी चाहिए. तो थीटा की वैल्यू कितनी आ रही? tan inverse square root of x by. So let's use all these three values into this equation. So a times tan inverse root of x by a. Tan square theta is x by a. So minus a times square root of x by a plus a times tan inverse square root of x by a plus c. So I guess this is the answer given on the back side of the exemplar also. So they have just taken out a. उन्होंने a common लिया हुआ and they have written x by a tan inverse square root of x by a minus square root of x by a plus tan inverse square root of x by a plus c. So हमने a common ले लिया and this is the result given on the back side of the exemplar also. So let's move to our next problem. Okay, so in this integral we have to integrate from pi by 3 to pi by 2 and integral is square root of 1 plus cos x. and 1 minus cos x की power 5/2. So ऊपर नीचे फ्रैक्शनल पावर आ रहा है एंड वी नो हम स्क्वायर रूट ऑफ 1 प्लस cos x को रैशनलाइज कर सकते हैं. So I'll do that so that हमारा जो पावर्स हैं वो एटलीस्ट इंटीजर बन जाए. So I will multiply with root of 1 minus x, 1 minus cos x. तो इससे ऊपर वाला टर्म सिंप्लीफाई हो जाएगा एंड दिस टर्म विल गो एंड मल्टीप्लाई विद in denominator also, right? This is 1 minus cos x की power half. So with this our integral simplifies to pi by 3 to pi by 2. ऊपर आ रहा है square root of 1 minus cos square x, which is just sin x, and नीचे आ रहा है 1 minus cos x का whole cube, right? ठीक है. So this integral is now pi by 3 to pi by 2 sin x divided by 1 minus cos x whole cube. So now this is a very simple question. We can just take 1 minus cos x is equal to t and इसका differentiation 0, cos x का differentiation minus sin x, so plus sin x into dx is dt and sin x dx हमारे पास available है. Sin x into dx is dt. So let's change the limits also. So when x is pi by 3, then t की वैल्यू आ रही है 1 minus cos pi by 3. Cos pi by 3 half होता है, then t is 1 minus half, which is half. And when x is pi by 2, so t is 1 minus cos pi by 2. Cos pi by 2 0 होता है, then t is 1. So our new limits are from half to 1. So integral is going from half to 1 and sin x dx is dt and we have denominator में t cube. So which is minus half to 1 t की power minus 3 का integral, which is t की power minus 2 divided by minus 2. So before putting in the numbers, just तो थोड़ा सा simplify कर लेते हैं. Let's insert some space here. Okay, so we have minus half outside and function is 1 by t square, right? Okay, half to 1. So minus half outside, 1 डालने पे आ रहा है 1 by 1 square minus 1 by half squared, which is half, 1 minus 4. So minus half into minus 3, which is 3 by 2, which is the same answer as the backside of the exemplar. Okay, so let's move to our next problem. So this is our next question. So in NCERT we have already done these two questions. So one of them as an example and one of them as a question from the exercise, and we got these results. So these are the standard NCERT questions, but हमने कोई ऐसा क्वेश्चन नहीं किया था वहाँ पे कि e की पावर x इंटू फॉर एग्जाम्पल cos स्क्वायर x को कैसे इंटीग्रेट करेंगे. तो ऑफ कोर्स बाय पार्ट से करेंगे, बट it will be very difficult if you just apply eyelet here. ठीक है, and so to make this question easy, what you can do is bring these quadratic terms and make them somehow linear. Okay, make them somehow linear. So we can integrate it just like the previous question. So we can do that. For example, here we can write cos square x as 1 plus cos 2x by 2, and we can solve two integrals. The first will be half times e की power x dx, and second will be half times e की पावर x into cos 2x dx. So इसको you can solve same as NCERT, right? ये तो हो गया. So this one you can solve same as NCERT. So idea is this कि हम इन polynomials को linear function बना देंगे किसी तरीके से. तो अब cubic को कैसे करें? This is more difficult. So we have a way to handle cubics. We have a formula for cos 3x, which is 4 cos cube x minus 3 cos x. From that, we can find the value of cos cube x. So cos cube x is nothing but cos 3x plus 3 times cos x divided by 4. So these are two linear terms, and our integral will suddenly become e की power minus 3x into cos 3x plus 3 times cos x divided by 4 into dx, and we can do two integrals. So first is 1 by 4 and then e की power minus 3x into cos 3x dx, and second integral is maybe 3 by 4 outside and then e की power minus 3x into cos x dx. So let's write them as I1 and I2. So I will say this is 1 by 4 times I1 plus 3 by 4 times I2. So let's solve for I1. So our integral I1 is integral of e की power. So इसको यहाँ ब्रैकेट में डाल देते हैं. Here we'll write the answer later. So e की power minus 3x into cos 3x, right? So let's use by parts here. So अगर आईलेट यूज करोगे so you will see कि let's take the trigonometric part outside, right? Okay. So I1 so e की power cos 3x outside, integral of e की power minus 3x dx, then ddx of cos 3x into integral of, so यहाँ पे ब्रैकेट यूज नहीं करते हैं, so into integral of e की power minus 3x dx. तो ब्रैकेट यहाँ यूज कर लेते हैं so that अब बाहर एक dx लगाना जो. So I1 is cos 3x e की power minus 3x divided by minus 3. यहाँ पे डिफरेंशिएट करेंगे इसको. So this is cos 3x का डिफरेंशिएशन is minus sin 3x divided by minus 3. So divide by 3. So minus 3, just 3 into e की power minus उसको डिफरेंशिएट करना है. I'm sorry. So 3 will come outside in the numerator. And then this integral is e की power minus 3x divided by minus 3. Okay. So this I1 is minus 1 by 3 e की power minus 3x cos 3x. Then this 3 and this 3 cancel and negative negative positive, but बाहर negative sign है. So this is e की power minus 3x into sin 3x dx. So we will have to apply by parts again. So I1 is minus 1 by 3 e की power minus 3x cos 3x. Then यहाँ पे by parts apply करेंगे तो let's use a bracket here. So let's take sin 3x outside. integral of e की power minus 3x dx minus sine d dx of sine 3x integral of e की power minus 3x dx and whole bracket dx. So I1 is minus 1 by 3 e की power minus 3x cos 3x minus, तो ब्रैकेट के अंदर आ रहा है साइन 3x इंटू ई की पावर माइनस 3x डिवाइडेड बाय माइनस 3 एंड देन इस टर्म का डिफरेंशिएशन इज साइन 3x का डिफरेंशिएशन इज cos 3x इंटू 3 एंड जो सेकेंड टर्म है उसका इंटीग्रल है ई की पावर माइनस 3x डिवाइडेड बाय माइनस 3 सो इंटू डी एक्स. तो यहाँ माइनस एंड माइनस प्लस, सो प्लस 1 बाई 3 ई की पावर माइनस 3x इंटू साइन 3x एंड इस टर्म में नेगेटिव एंड देर आर 3 नेगेटिव्स राइट. सो सेकेंड टर्म में तो नेगेटिव यहाँ पे है, एक यहाँ पे और एक बाहर है, तो नेगेटिव 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 इज नेगेटिव एंड वी हैव 3 and 3 cancels and we have integral of so these two cancel right. Okay. And e की power minus 3x into cos 3x dx, so which is our original integral I1 right. ठीक है, this was I1, so I1 मिल गया. So this is I1. So I1 goes to the left side, so twice of I1 is this. So you can take 1 by 3 outside, e की power minus 3x outside, and you get minus cos 3x plus sin 3x, and you can divide by 2 to find I1 is e की power minus 3x divided by 6 into sin 3x minus cos 3x. Okay. Probably I will just write it again. Okay. Now let's calculate I2. So long question, huh? I2. So I2 हमने छोड़ा था. So e की power minus 3x ये रहा into cos x. So I2 is e की power minus 3x into cos x. So let's apply by parts again. So this cos x goes outside. Integral of e की power minus 3x dx minus sin then d dx of cos x integral of e की power minus 3x dx whole bracket dx. So cos x into e की power minus 3x divided by 3 minus in cos x का differentiation minus sin x into e की power minus 3x divided by 3 dx. So this is e की power minus 3x by 3 into cos x. Then minus and minus becomes plus and 1 by 3 can go outside and integral of e की power minus 3x into sin x dx. So for which we will apply by parts again. So we have e to the power minus 3x. So this is the value of I2, right? तो यहाँ बाय पार्ट्स लगाने के लिए ब्रैकेट यूज कर लेते हैं. So let's take sin x outside. Integral of e की power minus 3x dx minus sign differentiation of sin x integral of e की power minus 3x dx bracket closed dx. So I2 is sin x e की power minus 3x divided by minus 3, and then sin x का differentiation is cos x and e की power minus 3x divided by minus 3 dx. So let's multiply and separate out all the terms. So I2 is, तो यहाँ पे divided by 3 है, divide by 3 है, so e की power minus 3x divided by 3, so into cos x. So this positive into negative is negative, minus 1 by 6, so minus 1 by 6, so ये भी 3 है, so minus 1 by 9, so right 1 by 3 था outside, so 1 by 9, e की power minus 3x into sin x, then minus and minus plus and plus 1 by 9 e की power minus 3x into cos x. So I'll put it in a bracket कि this was our original integral I2, not 1 by 9 but this one, right? ठीक है, तो इस बार 1 by 9 का एक फैक्टर आ रहा, so I get I2 minus 1 by 9 times I2. तो यहाँ पे you can take e की power minus 3x outside and probably divided by 9 बाहर ले लेते हैं, 9 का 9 बाहर ले लेते हैं, so inside we will be left with 3 cos x. तो मैं इन दोनों टर्म्स को देख रहा हूँ, 3 cos x minus sin x, so this one is I2, right? ठीक है ना, उसको मैं लेफ्ट साइड पे ले गया, राइट? So 8 by 9 I2, ये किसके बराबर आएगा? तो ठीक है, so e की पावर minus 3x 3 cos x minus sin x by 9, so इस 9 से इस 9 को कैंसिल कर देते हैं एंड 8 से डिवाइड कर देते, so I2 is 1/8, so e की पावर minus 3x 3 cos x minus sin x. So let's find now our result. So our result was 1 by 4 I1 plus 3 by 4 I2. Yes, so let's see. So our result was ये रहा 1 by 4 I1 plus 3 by 4 I2. So 1 by 4 I1 plus 3 by 4 I2. So this is 1 by 4 times I1, which is e की power minus 3x by 6 and साथ में ब्रैकेट में क्या था, sin 3x minus cos 3x plus 3 by 4 times e की power minus 3x by 8 3 cos x minus sin x and plus some arbitrary constant c. So our result is e की power minus 3x by 24 into sin 3x minus cos 3x plus कुछ गड़बड़ हो गया है. या सो ये जो इंटीग्रल है इसको करने के बाद यहाँ पे -3 आएगा. करेक्ट. सो outside there will be a negative sign. So let's change the signs. So negative, negative, and जब इनको multiply करेंगे तो this second term okay, so same negative का mistake यहाँ पे भी है. This is negative, this is negative, this is negative, this is negative, and after multiplication this term will become positive. This is negative, and negative, 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 this is negative. Okay, so let's तो उसकी वजह से क्या होगा कि this will become -1/9 times I2, and that's let's see, yeah, so this -1/9 I2 यहाँ पे, so when it goes to the left side it will become +1/9, so this will be 10/9, and यहाँ पे नेगेटिव और पॉजिटिव में क्या मिस्टेक है. सो yeah, so this is minus and this is plus, so minus plus माइनस प्लस एंड यहाँ पे नीचे क्या आएगा 10 आएगा. ओके, तो लेट्स चेंज दैट नंबर हियर. तो ये सेकंड वाला इंटीग्रल चेंज हो जाएगा. सो दिस इज e की पावर -3x by 10, and you can write it as sin x minus cos 3x, 3 cos x, I'm sorry. Okay, so this is 3 by 40 times e की पावर -3x into sin x minus 3 cos x. Okay, so this is the result that is given in the back side of the exemplar also. It was a very long question, so one or two small mistakes happened in between. So, but uh, let's put the answer from the back side of the book here also, so that you can verify if this is the answer. So, okay. So same result as the back side of the book. So let's move to our next problem. Okay, so in this question we have to integrate root tan x. So the substitution is given in the question, so let's use that. So let's put tan x is equal to t square. So but हम tan x को अगर हम differentiate करेंगे तो we will get secant square x, so which if it is not available you can just write this equation as x is equal to tan inverse t square. So you can find just the value of dx. So जिसकी वैल्यू कितनी आएगी 1 by 1 plus t की power 4 and then t square का differentiation is 2t and then dt. So I will use this as the value of dx, and now my integral will change and this will be integral of root of t square and dx की जगह आएगा 1 by 1 plus t4 into 2t dt. So this integral is twice of t square divided by 1 plus t4 dt. So this is a question from the miscellaneous से है, miscellaneous from NCERT. So so we'll proceed it in the similar way. So let's see, this is t square plus t square divided by t4 plus 1 dt. So what I will do is add 1 and subtract 1. So let's add 1 and subtract 1. So we have two integrals now. पहला है t square plus 1 divided by t4 plus 1 dt, and second integral है t square minus 1 divided by t4 minus 1 plus 1 dt. So let's divide by t square in the numerator and denominator, and we will get, so divide by t square in numerator and denominator. So we get 1 by 1 1 plus 1 by t square, and यहाँ पे आएगा t square plus 1 by t square dt, and यहाँ पे you will get 1 minus 1 by t square, and in the denominator you will get t square plus 1 by t square. So to solve it further, we will form some squares, and we please notice कि t plus 1 by t का जो डेरिवेटिव होता है, so that is 1 minus 1 by t square. So इस denominator में I will try to create t minus 1 by t somehow, and t minus 1 by t का डेरिवेटिव, इसका डेरिवेटिव is 1 plus 1 by t square. So इस denominator में I will try to create t minus 1 by t. So is the t minus 1 by t create करने के लिए I will do minus 2 and plus 2, and here I will do plus 2 and minus 2. So in doing that, my two integrals will be 1 by 1 plus t square, and यहाँ पे t minus 1 by t whole square plus 2, which is root 2 square dt, and यहाँ पे 1 minus 1 by t square, and denominator में I will get t plus 1 by t whole square and minus 2, which is minus root 2 square. So in both of these I can do my substitution now. So for example, पहले integral में we can do a substitution. T minus 1 by t is equal to some z, and 1 plus 1 by t square into dt will be dz. So this integral will change, and this will become dz and 1 by z square plus root 2 square, whose integral is 1 by a, so 1 by root 2 tan inverse z by a, so z by root 2. Okay, in the second integral, what you can do is put t plus 1 by t is equal to some, let's say, v or u. So and you will get 1 minus 1 by t square into dt is du, and this integral will become du and 1 by u square minus root 2 square. So whose integral is so let's just put more space here. Okay, so this integral is 1 by 2a log mod u minus a by u plus a. Okay, so our result z की वैल्यू डाल देते हैं. So z की वैल्यू was t minus 1 by t. So 1 by root 2 tan inverse t minus 1 by t by root 2 plus 1 by 2 root 2 u की वैल्यू t plus 1 by t. So t plus 1 by t minus root 2 divided by t plus 1 by t plus root 2 plus c. But our question was in terms of x, क्योंकि हमारा क्वेश्चन था tan root x, हमें t की वैल्यू भी डालनी है. So t is root of tan x. So we already know that. So I guess we will require more space here. So इधर पहले इसको सिंप्लीफाई कर लेते हैं. This is 1 by root 2 tan inverse t square minus 1 by 2 root 2 into t plus 1 by 2 root 2 log t square minus 2 root t minus root 2 t, I'm sorry, root 2 t, and plus 1 divided by t square plus root 2 t plus 1. So we will use that t was root of tan x, right? Okay, ये हमने यही यूज किया था, tan x is equal to t square, right? तो t square की जगह हम tan x डाल देंगे and t की जगह root tan x. So our result is 1 by root 2 tan inverse tan x minus 1 divided by root of, and ये भी रूट के अंदर है, सो ठीक है, तो एक ही रूट लिख देते हैं, प्लस 1 by 2 root 2 log tan x minus root of 2 tan x जो पूरा रूट में है प्लस 1 divided by tan x plus root 2 tan x plus 1. Okay, so let's move to our next problem. So again we have a very good question here from the exemplar. So here लग रहा है denominator में quadratic है, but if there is a perfect square also, so this here is a fourth order polynomial in the denominator. So it's suggesting divide by cos 4x. So we have done these questions like कि अगर you have a cos square x plus b sin square x plus some other quadratic term, let's say a cos x sin x, it is c cos x sin x plus some d. So you can do these questions, right, by dividing by cos square x. So in numerator you will get secant square x and denominator में क्या आएगा, a plus b tan square x plus c tan x plus d secant square, which can be written as 1 plus tan square. So in denominator you will get a quadratic in tan and secant square available, and then you can put tan x is equal to some z and secant square dx will be dz as a substitution. So 1 and 2. But यहाँ पे क्या है, fourth order है, so we'll divide by cos की power 4. So let's try that. So let me remove this. So let's divide by cos की power 4 and our integral will become 0 to pi by 2 and numerator में क्या आएगा, secant 4. एंड जब cos की पावर 4 इस स्क्वायर में जाएगा, इट विल बिकम cos स्क्वायर एंड इट विल बिकम a स्क्वायर प्लस b स्क्वायर tan स्क्वायर x होल स्क्वायर. यू कैन चेक दैट, राइट. ठीक है, आप यहाँ पे cos 4 से डिवाइड करोगे. इफ यू डिवाइड बाय cos 4 हेयर, तो स्क्वायर में जाने के बाद इट विल बिकम cos स्क्वायर, तो a स्क्वायर एंड sin स्क्वायर बाय cos स्क्वायर tan स्क्वायर. ओके, तो अब यहाँ पे सीकेंड स्क्वायर चाहिए हमें सब्स्टिट्यूशन के लिए. सो व्हाट विल यू डू इज एक सीकेंड स्क्वायर को सेपरेट कर लेंगे. 0 टू पाई बाय 2 है, तो 0 टू पाई बाय 2. पहले वाले सीकेंड स्क्वायर को मैं लिख रहा हूँ 1 प्लस tan स्क्वायर, एंड दिस इज फॉर सब्स्टिट्यूशन. So now let's use tan x is equal to z. So secant square x into dx is some dz. So our integral will become 0. So limits भी change कर देते. So when x is 0, z is tan 0, so z is 0. When x is pi by 2, z is tan pi by 2, so we'll take it to be infinity. So our limits are 0 to infinity. 1 plus z square divided by 1 plus a square plus b square z square की power 2 and secant square x into dx is dz. So ठीक है, our trigonometric integral has now become some kind of partial fraction, and हमारे limits have also changed from 0 to infinity. So what now? So now so looking at z square in the numerator and denominator, what I will do is I will put z square is equal to some t, but only for partial fraction. Z square is equal to t, but only for partial fractions. And this will become 1 plus t divided by a square plus b square t whole square. And please remember partial fractions. Uh, if you have some ax plus b divided by x, let's say px plus q divided by x plus a का whole square, तो इसका partial fraction you can do as a by x plus a, and since root is repeating, so b by x plus a whole square, right? So I'm just taking it from NCERT. So for this partial fraction, I will do it as a by a square plus b square t plus b by a square plus b square t whole square. So let's find the value of capital A and capital B in this equation. So we find 1 plus t is equal to a times a square plus b square t plus b. So denominator हमने cancel कर दिया LCM लेने के बाद. And now let's compare the coefficients. So coefficient of t, so we can find LHS में 1 है, RHS में coefficient of t is a times b square. तो हमें किसकी वैल्यू निकालनी है? कैपिटल ए की. सो कैपिटल ए इज 1 by b square. And let's find constant coefficient which is 1 on the left side, and RHS में है वो a square plus b. So we have already the value of a, which is 1 by b square. So we find 1 a square by b square plus b, and we find b is equal to 1 minus a square by b square, and b is b square minus a square by b square. Okay, so we have found the value of b and a. So now let's put these values in the partial fraction and write our integral. So, so from this partial fraction and this substitution, so from this partial fraction and this substitution, we can write this integral as 0 to infinity, and पहला होगा a, तो a was 1 by b square divided by a square plus b square t, a square plus b square, but t क्या था, z square, right? Okay. Plus, so plus we have the value of b also, which one was, which is b square minus a square by b square. So b square minus a square by b square divided by a square plus b square t, but t है z square, इसका whole square. d z. So our first integral is 1 by b square and 0 to infinity and 1 by b square z square plus a square dz. Second integral is b square minus a square by b square, 0 to infinity, 1 by b square z square plus a square का whole square dz. तो पहला वाला तो लग रहा है सॉल्व हो जाएगा, बट अबाउट द सेकंड वन. So first integral तो probably हो गया, we can take b square outside, तो 1 by b4, 0 to infinity, 1 by z square plus a square by b square, so which is a by b का whole square. So then you can write it as 1 by b4, 1 by a by b, tan inverse z by a by b, but the limits are 0 to infinity. But this one I will call plus b square minus a square by b square into I2. I2 we will calculate separately. So plus में b square minus a square by b square into I2. So this is 1 by a into b cube and tan inverse b by a z, and limits are 0 to infinity. So let's apply the limit here. So this so um, hmm. So this is 1 by a b cube, tan inverse infinity minus tan inverse 0. So this is 1 by a b cube, pi by 2 minus 0. So this is pi by 2 a b cube. Okay. And plus b square minus a square by b square times I2. So plus b square minus a square by b square times I2, और I2 क्या था हमारा? So that is the difficult one. तो उसके लिए आपको एक इंटीग्रल सीखना पड़ेगा. So let's do a very simple integral पहले तो. So I2, so I2 is 0 to infinity z square by, okay, so there's a quadratic ka whole square, right? So I'll teach a simple integral first, so then we can apply it there. Okay, so let's learn how to integrate 1 by 1 plus x square squared, okay, and let's say 0 to infinity mein. So to do this question, you can put x is equal to tan theta. So dx will become secant square theta d theta, and your limits will change from so when x is 0, uh, so theta is tan inverse x, so tan inverse 0 is 0, and when x is infinity, and tan inverse infinity will be pi by 2, so theta is pi by 2. So let's see. So 0 to infinity, 1 by 1 plus tan square theta whole square secant square theta d theta, and limits are now 0 to pi by 2, I'm sorry. So, and this is 0 to pi by 2 secant square theta by secant 4 theta. तो एक secant स्क्वायर कैंसिल हो गया, नीचे क्या बचेगा secant स्क्वायर थीटा, एंड वो न्यूमरेटर में जाके क्या बन जाएगा cos स्क्वायर थीटा, एंड वी ऑल नो हाउ टू इंटीग्रेट cos स्क्वायर थीटा, राइट? So you can apply double angle formula, or so you can write it as 1 plus cos 2 theta by 2, and proceed further. So now let's try to solve I2. Okay, so I will put this in a box. I will insert some space. Okay, so let's try to calculate I2 now. So I2 is 0 to infinity 1 by so b square z square plus a square dz. So b square z square plus a square whole square dz. So to do this integral, let's take b square outside, so it will become b4. तो यहाँ पे b की पावर 4 बाहर आ गया डिनोमिनेटर में, 0 to infinity, and we are left with z square plus a square plus by b square. तो या फिर you can write a by b का whole square ठीक है. Okay, dz. Okay, so I2 is 1 by b4, and let's use our substitution now. So यहाँ पे substitution करते हैं, and instead of this let's do substitution, and हम z की जगह डाल देंगे a by b tan theta. ठीक है, so let's use z की जगह a by b tan theta. So dz is nothing but a by b secant square theta d theta. So our integral will change now, and this will become I2 is 1 by b4, and limits भी change कर देते हैं. So when z is 0, theta, so जब z 0 आएगा tan theta is 0, तो theta is 0, and when z is infinity, so tan theta is infinity, so theta is pi by 2. So our limits will go from 0 to pi by 2, and we have 1 by z की जगह आएगा a by b into tan theta, so this whole square plus a by b whole square and dz की जगह आएगा a by b secant square theta d theta. Okay, so lots of terms, but well, this one was a difficult one. So I2, so a by b 5 एंड यहाँ पे क्या करते हैं, a by b बाहर निकाल लेते हैं डिनोमिनेटर में से, तो आई गेट a, सो a स्क्वायर b स्क्वायर यहाँ पे भी है, a स्क्वायर b स्क्वायर यहाँ पे भी है, बट परफेक्ट स्क्वायर है, तो a स्क्वायर b स्क्वायर बाहर निकालें तो a4 b4 विल कम आउटसाइड एंड इनसाइड आई विल बी लेफ्ट विद tan स्क्वायर थीटा प्लस 1 होल स्क्वायर d secant square theta d theta. So secant square theta d theta. So I2 is, तो नीचे बच रहा है 1 बाई ए क्यूब और b बच रहा है, ठीक है, 0 to pi by 2 secant square theta by secant 4 theta. तो थोड़ा बहुत a और b को हमें हैंडल करना था, बाकी इंटीग्रल वाज सेम एज द प्रीवियस वन, सो जो मैंने एग्जांपल दिया ऊपर. तो I2 is 1 by a cube b, so integral of cos square theta. So I2 is 1 by a cube b, 0 to pi by 2 integral of 1 plus cos 2 theta by 2. So I2, तो 2 बाहर आया एंड पहला इंटीग्रल है डी थीटा का 0 to pi by 2 प्लस 1 by 2 a cube b एंड 0 to pi by 2 में इंटीग्रल है cos 2 theta का. So this is 1 by 2 a cube b, d theta का इंटीग्रेशन थीटा, लिमिट्स आर 0 to pi by 2, so this is pi by 2 minus 0 and 1 by 2 a cube b, cos 2 theta का इंटीग्रेशन है sin 2 theta divided by 2, लिमिट्स आर 0 to pi by 2. So this is pi by 4 and नीचे है a cube b plus 1 by 4 a cube b and sin pi by 2 डालने पे this is sin pi which is 0, 0 डालने पे this is 0, sin 0, so which is also 0. So we are left with pi by 4 and a cube b. Okay, so let's write our final result for this question. So result, so we'll note it down from above. So above we calculated our answer to be pi by 2 a cube a b cube. So let's check if it was pi by 2. Yeah, so so let's we can copy this or I can just write it below. So pi by 2 a b cube and b square minus a square by b square into I2. So pi by 2 a b cube plus में b square minus a square by b square into I2. So by b square into I2. So this one was I2, right? Okay. तो ये पूरा हमने कैलकुलेशन किया. So into pi by 4 a cube b. Okay, so let's take whatever we can take common. So pi बाहर ले लेते हैं, डिनोमिनेटर से 2 और a और b क्यूब. तो फर्स्ट टर्म में से क्या बच रहा है, पूरा का पूरे टर्म ही बाहर आ गया, 1 बच रहा है। सेकेंड टर्म में बच रहा है बी स्क्वायर माइनस ए स्क्वायर, एंड डिनोमिनेटर में हमने ए बाहर लिया और बी क्यूब, सो ए 2a स्क्वायर बच रहा है। So this is pi by 2ab cube into 2a square plus b square minus a square divided by 2a square, which is pi by 2ab cube. ऊपर आ रहा है a square plus b square और नीचे आ रहा है 2a square. So simplifies to pi into a square plus b square divided by 4 into a cube b cube. So one of the toughest question from the exemplar, but we went through it. So let's move to next problem. Okay, so this looks like a question from by parts. So let's just focus on the indefinite integral first. We will apply the limits later. So this is x into log of 1 plus 2x dx. And if you look at isolate, so one of the term is logarithmic, other one is algebraic. So this one is log of 1 plus 2x and this is x. So let's take difficult term outside, which is log. So log of 1 plus 2x outside, integration of x dx minus d dx of log of 1 plus 2x into integration of x dx and whole dx integral. So this is x square by 2 into log of 1 plus 2x minus, इसका डिफरेंशिएशन होगा 1 by 1 plus 2x into 2 and integral होगा x square by 2, so 2 cancels dx. So second वाले इंटीग्रल में now, which is x square by 2x plus 1, right? So this one should be done using long division क्योंकि न्यूमरेटर का पावर बड़ा है, डिनोमिनेटर का छोटा है, so we can do long division here. So we can write x square here and 2x plus 1 here. So I will multiply with half x here. It will become x square plus half x and subtract करेंगे. So I'll be left with minus half x and then I'll multiply with minus 1 by 4. So minus 1 by 4 into 2 is minus half x. So minus half x minus 1 by 4, and now sign changes again. So plus plus and remainder is 1 by 4. So I can do in the second integral px. So यहाँ पे मैं जो न्यूमरेटर है which is the dividend can be written as divisor 2x plus 1 into quotient which is half x minus 1 by 4 plus remainder which is 1 by 4 divided by 2x plus 1. तो 2x plus 1 cancel कर देंगे. So x square by 2 log of 1 plus 2x and पहला इंटीग्रल आ रहा है तो बाहर नेगेटिव साइन है, प्लीज नोटिस, राइट. तो पहला इंटीग्रल आ रहा है half x minus 1 by 4 into dx, and this negative will multiply with 1 by 4 also, so you can take maybe 1 by 4 outside and 1 by 2x plus 1 dx. So let's complete this. So x square by 2 log of 1 plus 2x minus half times x का integral is x square by 2 and minus minus plus and dx का integration x and plus 1 by 4, इसका integral will be log of log mod 2x plus 1 divided by 2 Okay. So, and now all we have to do is, so this is the integral of, let's see, x into log of 1 plus 2x, right? Okay. And we have to calculate by just putting in the limits now. So limits लगाते हैं, and limits are 0 to 1, है ना? So 0 to 1 limits लगाने. So 0 to 1 x times log of 1 plus 2x. So this is x square by 2 log of 1 plus 2x. इस पे लिमिट्स लगाते हैं 0 to 1. अगला टर्म है माइनस 1 बाई 4 एक्स स्क्वायर. इस पे लिमिट्स लगाते हैं 0 to 1. प्लस 1 बाई 4 एक्स 0 to 1. प्लस 1 बाई 8 इंटू लॉग ऑफ नॉट 2x प्लस 1. इस पे लिमिट्स क्या है 0 to 1. तो दिस इज 1 डालने पे 1 बाई 2 log mod 3, log 3 माइनस 0 डालने पे 0 इंटू log 1. log 1 कितना होता है 0. दिस टर्म गोज टू 0. माइनस 1 बाय 4. 1 माइनस 0 प्लस 1 बाय 4. 1 माइनस 0 प्लस 1 बाय 8. And inside terms are log. So log 3, 1 डालने पे 3 आ रहा है, माइनस log 1. तो log 1 is 0. So our result is half log 3 plus 1 by 8th of log 3. So let's add these two by taking log 3 common. So log 3 common. Half plus 1 by 8. So LCM is 8. 4 plus 1. तो कुछ मिस्टेक तो नहीं हुआ. मेरे को लग रहा है एक नेगेटिव का मिस्टेक हो गया. So let's check. So this negative will make this one negative, and also the second integral also negative. So this is negative. Okay, so answer में यहाँ पे negative आएगा. So which will change not much, but ये negative हो जाएगा. So this number is negative and this number is negative. So yeah, and our answer is ऊपर 4 minus 1. So answer is 3 by 8 log 3, same as the answer on the back side of the book. So let's move to next problem. Okay, so this in this question we have to use properties of definite integration. So I is 0 to pi x log sin x. So log sin x हमने NCERT में भी integrate किया हुआ है, and we'll do it here again. So but we have to eliminate this x, so let's use the property 0 to a f of x dx is same as 0 to a f of a minus x into dx. So this will change the integral. So I will become 0 to pi minus x into log of sine pi minus x. So sine of pi minus x is just sine x. So this is 0 to pi minus x into log sine x dx. And what we will do, like always, is add 1 and 2. So 1 plus 2 will give you twice of I is equal to 0 to pi. So x plus pi minus x, तो pi बचेगा बस into log sin x. And let's take pi outside, pi by 2 times 0 to pi log sin x dx. So this is a question from NCERT examples. So this is a NCERT example. एंड वहाँ पे आपने निकाला होगा 0 to pi log sin x dx एंड इसकी वैल्यू आई होगी pi by 2 log half. And so you can use the direct value if you remember that. So I की result आ जाएगी आपके पास pi by 2 into pi by 2 log half. So this will be pi square by 4 log half. But let's just solve this integral. ठीक है? So let's say this is our integral I. So how can we solve this one? So we will use our first property ki 0 to 2a fx dx can be equal to twice of 0 to a fx dx, and this is only true if f of 2a minus x is equal to fx. So let's try that. So our fx for this function is log sin x, and let's find f of 2a minus x. So limit is 2a, right? So this is 2a, 2a is pi. So f of 2a minus x कितना है? f of pi minus x, and this is log of sin pi minus x. So which is basically log sin x. So this property is satisfied, and we can double this integral bit in the limit 0 to pi by 2. Okay. So from our property, okay, we get I is pi by 2. Then I can write twice of 0 to pi by 2 log sin x का integral. So our integral is pi times 0 to pi by 2 log sin x. So I will call this particular equation as our third equation, because I think I've already created 1 and 2, so I will call it third. Then I will apply our previous rule again, कि 0 to a fx dx is same as 0 to a f of a minus x dx, and this time pi by 2 minus x आएगा यहाँ पे, and pi by 2 minus sin of pi by 2 minus x is cos x, and our new integral will become pi times 0 to pi by 2 log cos x dx. I will call it fourth, and then we will add third and fourth now. So 3 plus 4, तो हमें मिलेगा twice of I, which is pi common, and 0 to pi by 2 log sin x dx plus 0 to pi by 2 log cos x dx. तो log and log एडिशन में क्या होगा? मल्टीप्लाई हो जाएगा. So I is pi by 2 times 0 to pi by 2 log of sin x into cos x dx. So what we can do in here is multiply and divide by 2 inside. Okay. So our integral will change and it will become pi by 2, 0 to pi by 2. So पहला टर्म आ रहा है log sin 2x and minus log 2. So now let's just split and write two integrals. तो पहला है I pi by 2, 0 to pi by 2 log sin 2x dx minus pi by 2 log 2. So minus pi by 2 log 2 and integral of dx बचेगा यहाँ पे. and limits are 0 to pi by 2. So in the first integral, we can do a substitution. So 2x is equal to z, twice of dx is dz, and dx की जगह we can write half dz, and limits. So when x is 0, z is 0, and when x is pi by 2, z is pi. So our first integral will become pi by 2 times 0 to pi log sine z into half dz and minus pi by 2 log 2, and dx का integration x, and limits are pi by 2 to 0, so pi by 2 minus 0. So this is pi by 4, 0 to pi log sine z dz minus pi square by 4. This was log कितना था, log 2 था, I'm sorry. So if you just check here, this one was log 2. ठीक है, this is log 2. Okay, so but what about, so this integral we have already encountered, right? So I marked it as third or fourth. So if we look carefully at the third equation, okay, so pi times 0 to pi by 2 log sin x dx is, okay, so this integral was in I itself, right? So let's keep pi here, okay, and 1 by 4 outside, okay. So this integral was I itself, right? So I is 1 by 4 times I minus pi square by 4 log 2. So some mistake. Yeah. So that third equation was from 0 to pi by 2. So third equation is from 0 to pi by 2. We have to see above here. So 0 to pi wala, right? I is so this one. So I will mark this as star equation. Okay? So from star equation, pi by 2 times 0 to pi by 2 log sin x dx is I. So this is 0 to pi. वो वाला 0 to pi by 2 था, so थोड़ा mistake हो जाता वहाँ पे. But yeah, so pi by 2 रखना है मुझे यहाँ पे, ठीक है. So outside I'll be left with 2, and this is I, right? ठीक है, this particular integral is I, so I get half times I is equal to minus pi square by 4 log 2, and 2 cancels. To find I, we can find I is minus pi square by 2 log 2. Okay, so let's move to our next problem. Okay, so this is the last long question. So let's solve this. So let's try to simplify it from inside. So minus pi by 4 to pi by 4 uh, log, and I'll multiply with the and divide by root 2. So 1 by root 2. Uh, so I'll keep root 2 outside. 1 by root 2 sin x plus 1 by root 2 cos x. So now I can write, so this one was, let's say, I, right? This is the original integral I. So I minus pi by 4 to pi by 4 log root 2 plus log of, so sin x into cos pi by 4 plus cos x into sin pi by 4, it is sin of x plus pi by 4. So I may, we can take log root 2 outside, and dx का integration 0 minus pi by 4 to pi by 4. Second integral में we have minus pi by 4 to pi by 4 log of sin x plus pi by 4. So पहला इंटीग्रल तो हो गया, तो दिस इज पाई बाय 4 प्लस पाई बाय 4, तो x आ जाएगा एंड पाई बाय 4 माइनस में माइनस पाई बाय 4, तो दिस इज log रूट 2, तो पाई बाय 4 प्लस पाई बाय 4. सेकेंड इंटीग्रल में को लेट्स कॉल, यहाँ पे वी विल डू सब्स्टिट्यूशन x प्लस पाई बाय 4 को हम डाल देते हैं z, तो x प्लस पाई बाय 4 लेट्स से z, तो dx is dz. So when x is minus pi by 4, so z is 0, and when x is pi by 4, so pi by 4 plus pi by 4, z is pi by 2. So our new limits are 0 to pi by 2, and this will become log of sin z and dz. So this is the same question from NCERT. This time I will not solve this. Okay, and इसका result will be pi by 2 log half. Okay, and plus में we are getting pi by 2 log root 2. So you can combine both of these results क्योंकि let's see. So इस root को अगर हम बाहर ले जाएंगे, so this will become pi by 2 into half, right? क्योंकि power half है into log 2. ठीक है. And इसमें से हम 2 की power, this is 2 की power minus 1, so we will take negative outside. This is log 2. So our result is pi by 4 log 2 minus pi by 2 log 2. So our final result is minus pi by 4 log 2. Okay. So same result as the exemplar. So thank you for watching. Like, share and subscribe, and the notes will be available below the video, and so will be the timestamps. Okay.